So, Module 3, Part 3, we are still talking about AI in large systems and what happens when you integrate AI in large systems. One of the most important thing when you have AI in large system is the concepts of AI governance. So this refers to the policies and regulations and laws, procedures that control the use of AI in your institute or organization. It is the way that um, the AI system is developed, deployed, and used. We want to make sure that it is used in an ethical way. And if you remember, we were talking about transparency, explainability, and then fairness, and so on. So accountability also. So it's the responsible management actually that use AI. So this means that you have a set of guidelines that you are following. For example, if you are in EU, you have the EU guidelines and regulations for AI, for example, which is quite new document now. So you have to follow these things and best practices also for AI development. So this is very important to ensure that the AI system is developed as is intended to be, and it is fair, transparent, and accountable. These frameworks that you will follow, basically very important for organizations to know that to minimize the risk associated with AI and to make sure that they are aligned with the ethical and legal standards. And you will not be sued later on for using this AI in an intended way. There are many things, many frameworks to follow. For example, the older one is the IEEE Global Initiative of Ethical Consideration in AI, Autonomous Systems. There is also a European Commission ethical guidelines for trustworthy AI. Also, there is now the AI regulations and the EU regulations for using AI. So as I said, there are many frameworks. For example, this is one of the framework for the defining, for example, what is performance, accuracy, privacy, transparency, and then the level of autonomous. For example, the level of autonomous depends actually which level of autonomous you have, and then the regulation and the governance will be different, of course. Disconnected, for example, this is like do things and may report manually any problems. Watching means level 2 means sensors observing and categorizing potentially to the driven analytics for other processes. Coaching means that level 1 is depending on the sensors, and then coaching means that human making the decision with the AI giving active tips and suggestions, but finally the decision is the hand of the human. Collaborating means that the AI making the decision and calling in the human, so somebody if the AI needs help. And autonomous means that no human in the loop, but still monitored. And from time to time, this monitoring report will go to some human to check for the things, for the issues. Another thing we have with the large system is the management of the model. So when you have many models and models are getting bigger and bigger, and you are frequently updating the model, means that you need to manage these models. It's not like you bring a model and you distract the old one and you just delete it. No. And also managing the model means that keeping an eye on the detail of this model also. So it's the process of managing machine learning models through their entire life cycle. So you develop, you train, and all these things. You are tracking, versioning, organizing these models, and also monitoring them. There are many tools for doing this. For example, for the version control of the code, you have Git and GitLab and GitHub and so on. You have the tracking and managing machine learning experiments during this process of the training the model or getting the model from somewhere. You have tools like MLflow, for example. You have Kubeflow also doing the same thing, but with the Kubernetes in the cloud and in the cluster. Um, you have data versioning control, which is like versioning of the data. And you have weight and bias, for example. We will use it in our labs for model training and monitoring. So this is very important. You have also sometimes you have feedback from the stakeholders, and you take into consideration this feedback in the model management when you manage the models. Quality management is the process of ensuring that the machine learning model and the whole system meet a necessary quality standard. If you remember during the governance also, we were talking about, for example, these standards and regulations. So the quality management, we want to make sure that we are meeting some quality metrics. So you have to also identify which metrics you want to follow, and which level of this metric you want to achieve. Measuring the model performance is very important here to identify the quality metric. And you want to make sure that the machine learning system in general is effective, reliable, and so on, and trustable by the quality management. Of course, there are many tools and metrics also for monitoring the quality. For example, metrics like accuracy, precision, and so on. These are standard metrics for monitoring. And also there are many other tools for data quality check, data validation, and data profiling tools. And also you have testing tools for testing accuracy from software engineering perspective. Um, so also nowadays there are many testing classical testing methodologies also can be used for quality management. Security is also important during these systems development. It is like protecting the AI system and its data from unauthorized access. So if the organization is depending a lot on the AI, so how to make sure that this AI and also this AI is trained automatically every week or every day. So how to make sure that this AI is not trained on a fake data or some data that has been introduced without your permission, and then how you make sure that in general this system that contain AI is protected from attackers, for example. So that is a general security issue. And also there is security issue related to the AI itself. And there's another security issue which is related to the system, the software system that is containing AI as a component. So there are many tools and strategies, of course, for doing this. You have to protect the AI system based on these strategies. Potential threats, for example. Also, there is one thing that since you have a lot of data, how to make sure that this data is not going out or is not stealed, is this data is not breached. So there are different dimensions of this security that you have to take care of. Um, and nowadays there are different tools integrated to the system in various stages. For example, there are tools for the data protection you integrate. There are tools for the machine learning itself for security. And the best thing is also to follow some security protocols when you have these systems. And for example, if some data breaches or some attack is available, is happening. So what is the protocol? Is it like you shut down the system in general, you cut off something? What is the protocol? What is the procedure to deal with this if happened? Deployment, as we said, we will come back to this also later on, is the process of making AI model available to the system. So this is very important. It includes also tools like continuous integration, continuous delivery, and then we will come back to this later on. But this is very important because finally the deployment is the identifying the way that the the way that system will be presented to the user. Finally, you have when you have the deployment, you have the monitoring. Also, we talked about this before, and we will talk about this later on. Also, is an essential component of AI system. So you cannot imagine an AI system without monitoring and logging. The monitoring is the process of tracking the performance and behavior of the AI. Because these AI system, there is a very large likelihood to have problems, faulty decisions, and so on. So you have to make sure that um, these systems are monitored and giving the right decision always. The logging involves recording the information continuously about this system and then coming back every now and then to see if there is a problem, or if there is a problem now, you have to go back to this login information to identify and relocate the problem, in which place, in which time, and where did happen. So for the fault tracking also. So there are many tools, as I said, cloud monitoring, cloud logging. So there are many things to include. There are standard tools. There are open source tool. For example, there is nowadays very famous tool called Evidently that helps for the monitoring and logging and so on. So basically the cloud monitoring tools, depending on alerts and notifications, also depends on the dashboards, and you have these dashboards. You can look at the numbers and the graphs, and you know the monitoring for that. Cloud login, you have log viewer and log-based metrics, and then you look at these things continuously. AI operations, we will come back to this in the next module, but it is generally when we say ML ops or AI ops, it is a set of practice and tools used to manage the life cycle of the AI model. So you can see until now we were talking about AI ops in general without naming it, but now you can see that, okay, if this AI, whatever AI is, it is in operation, it means I have to follow these steps. And these steps are monitoring, are governance, are quality assurance, are continuous integration, continuous delivery, and so on. So all these steps were taking us to the concept of AI operation, which is AI ops. So when you have a big organization and you want to deploy these AI things in the operation, then we have to follow the AI ops. AI ops basically means that this is the bigger picture when you have the AI application. But if you have the AI application and the AI application is based on machine learning, so we call this the lower level, which is the machine learning operation, ML ops. And the operation of the machine learning actually is two side. Is one side is the continuation, the operation of the data, which is data ops, and the focus on the model and the continuation of the model, the operation of the model, which means the model ops basically. So you have the data collected going to the storage, and this data is going for ops. And during this time, there is automation. You want to clean the data. You have to detect the change of the data. You want to detect the anomaly inside the data and so on. So this is basically the ops, the data ops, all these activities. There are many, many activities. And also you have like the activities related to the model, which is the model ops. You have auto ML, you have generalizability, you have concept drift, and so on.